Hey guys, so obviously I'm not at school today again. I apologize. Something came up and you are getting a video of me. It's very weird, it's very awkward. I get it. But hopefully, this will help you understand more about rational graphing. So, we're going to walk through a couple more things. So, just to recap, we're going to try to do this in one take, by the way. Just to recap, we talked about how to find the points of discontinuity. So remember, the points of discontinuity are your PODs, and that is where your denominator is set equal to 0. So we have to factor it using your magic X or your GCF, things like that. Then what we want to do is we want to figure out the numerator. So factor the numerator out and see if there's anything in common, binomials, monomials between the numerator and denominator. Anything that's in common is a whole. Anything that is not in common, that POD becomes the vertical asymptote. And that's really what your first 5 questions that I made you guys do on Monday was all about. Hopefully the Khan Academy video was a little bit helpful. I apologize if it was not. Hopefully this will be a little bit more helpful. Then once we determine the vertical asymptotes, we can draw them. Once we determine the x-coordinate of the whole, you're going to simplify your fraction, plug it back in, get the y-coordinate of the whole. Okay. After that, we want to test out the horizontal asymptotes. Again, we've already gone through that. Look up at your notes. What happens when the numerator is larger than your denominator? There's no horizontal asymptote. When your exponents are the same, then it's the fraction a divided by b. If your numerator is smaller than your denominator, then it's always at y is equal to 0. Just a side note, you're going to be getting back your homework, or you have gotten back your homework on those activity sheets. I noticed that on one side of your horizontal asymptotes, a lot of you guys just wrote numbers. Please don't write your numbers. Please actually write them as lines. That's what they are. So let's get into some really good habits about that. And on the other side, where it said to find your vertical asymptotes, I think it was 9. I don't have the paper in front of me. There was a couple of them that actually did not have 2 vertical asymptotes. It only had 1 vertical asymptote. And you guys forgot to, separate the numerator and the denominator out and all that wonderful stuff. Okay. So these are just little things that I want you guys to pay attention to, and I'll write this up onto my website. Sorry, also, I sometimes look at the camera and then I look at myself and then I look back at the camera, so it's weird. Sorry. Okay. So today what we're going to do is we're going to focus on the rest of these problems on your packet. And if I can find a Khan Academy video, I'll also upload it. You guys can watch that as well, but hopefully this will also help you. Okay. So today what we're going to do is we're going to talk about what's known as slant asymptotes. Okay. So what I want you to do right now is pause this video and go on to desmos.com, and you are going to type in the equation that I'm going to show you on a piece of paper. Okay, we're going to see if I can flip my camera around for that. All right, so once you see the equation, pause it, and I want you to go to Desmos, and I want you to type it in. Okay, cool. Let's see if I can flip this camera around. Nope, I just keep taking pictures of myself. All right, this is what you guys get. So let's see if this works. It is backwards. That's weird. Okay. So I'm going to stop this video and figure out what's happening, and we'll get back to it. Okay. All right, guys. We are back. I'm a genius. All right, now you don't have to stare at my face. I want you to pause the video and go onto desmos.com and type in this lovely equation right here. Okay, so notice I typed in our equation, y is equal to x squared plus 3x plus 2. X minus 2 is in our denominator, so points of discontinuity would be x is equal to 2. It does not if you factor it, you're not going to see anything in common between the numerator and denominator. There's no horizontal asymptote because the numerator is larger than the denominator. And so your graph actually looks like that. Okay? So notice that with this rational graph, right? Sorry for my hand being unshaky. So notice that we see, like right here, let me grab a pencil, right? X is equal to 2. Our graph is not going to cross 2, right? We don't have a horizontal asymptote, but it looks like there's something happening along this line and leading up to here, okay? This is known as a slant asymptote, right? So slant meaning that it's kind of on its side. It's still going to be a line. So if you think about it, vertical asymptotes are a horizontal line. Vertical asymptotes, right, are x is equal to, so it's a vertical line, my bad. Horizontal asymptotes is your y is equal to, so it'll be a horizontal line. So a slant asymptote will still be a line, and it'll be in the form of y is equal to mx plus b. Okay, so how do we actually determine how to find the slant asymptote? I want you to take out your notebooks, and I want you to copy this down. To find the slant asymptote, you must determine if there is no HA, meaning no horizontal asymptote. And the numerator needs to be exactly one more than the degree of the denominator. So if we look, and you can pause it to copy this down, but if you notice, this is weird, and right there, right? Notice that 2 versus 1, so we know that there's no horizontal asymptote. So how do we actually find this slant asymptote? You are going to use long division, okay? So use long division, all right? So you're going to put x minus 2, and you're going to say x squared plus 3x plus 2, okay? So again, ask yourself, how many times is x multiply to get x squared? We're going to say x times x squared, x times negative 2, so minus 2x, right? Take a subtraction, so this is going to turn to a subtraction. That will turn to an addition sign, right? That will cancel off. What are we left with? 5x. 5x plus 2. Bring down the 2, right? X times what gives you 5x? So positive 5. So 5 times x, 5x, minus 10. Bam. Subtraction, positive, crosses off, 12. Here's our remainder. We don't care about this remainder. Don't care. Okay? What we care about is this guy right here. Right? That is going to be our slant asymptote. It will always be a line. Sometimes these denominators will go evenly into the numerators, but most of the time they will not. All right? So your slant asymptote is in the form of y is equal to mx plus b. So it's going to be this. So for this problem, this example, what we call number 1, right, our slant asymptote, which I call SA, right, SA, no, it's like what you write in English, but I'm sorry. I'm trying to add a joke in here, but I can't tell if anyone's laughing. Hopefully Sam is, or Jackie. Carly might have gotten a good chuckle out of that one. Okay. So SA, so it's just going to be, again, y is equal to x plus 5. All right, so take a moment, pause this video, and write things down, right, in case you need to remember. All right, and you unpaused it. Fantastic. So notice what I put up here in blue. I said the x is equal to 2, so there is our vertical asymptote. So you see that right there. And now notice y is equal to x. So again, y is equal to x plus 5. So again, notice that this asymptote, right, is having the shape. So again, we're going to talk about how we can actually find out all of these different things. Okay, So let's try another one with practice, okay? So here we go. So let's find, so example 2, find the slant asymptote of y is equal to, 2x cubed plus 4x squared minus 9 all over 3 minus x squared. So what I want you guys to, it is very hard to film and to hold this straight up. Okay, so what I want you to do is I want you to pause this video and I want you to set up the equation, right, with long division. All right, so we're back. So you should have hopefully set up the equation as negative x squared, plus, you could say 0x plus 3. You don't really need the 0. That's fine. Okay. And then 2x cubed plus 4x squared. This one is important, though. We do need that 0x minus 9. Okay. So hopefully you set it up that way. Again, pause the video. Go ahead and finish the problem. If you need to, you can. You don't have to pause it. You can just listen to my voice. It's very soothing. So what do I multiply this guy to get to a positive 2x cubed? It'll be a negative 2x. So this will leave you with a positive 2x cubed. And then we will have a minus 6x. Nothing multiplies. So again, negative, positive, cancel out. Bring down the 4x squared plus 6x minus 9. Again, what do you multiply? You get to multiply minus 4. So negative into negative gives you a positive x squared. Nothing there. Minus 12. Negative. Positive. Cancels out. Bring down the 6x. And 9. Negative 9 and a positive 12. Leave you with a plus 3. Again, here's a remainder. We don't care about a remainder. So what is our slant asymptote? So our slant asymptote is y is equal to negative 2x minus 4. And then we would graph that. All right. So take a moment, check your work, and all that beautiful stuff. And what I want you to do is I want you to take out your homework, that the packet of rational graphing, and turn to, I think it's problem number 7. The one that looks like this. I left my homework at home, so that's all that I have. All right, so pause it and get it. Okay, so the first thing that we want to do is let's walk through this question together. I'm going to turn this a little bit differently. Maybe if I hold it like this. Okay, so the first thing we want to do under there is PODs. So PODs, we would set everything in our denominator equal to 0. So we just have one thing. So we have a point of discontinuity. It's the number 0, right? So it says holes and vertical asymptotes. So determine the, let's write holes, vertical asymptotes, right? So let's go ahead and factor that. So that becomes x plus 1, and this also becomes x plus 1. My bad. You are seeing all my mistakes live. It's very exciting. There we go. Okay, and over x. So, is anything in common? You're correct. No. So there are no holes. So none. Please write none. Don't write 0. Because if you write 0, I'm going to assume that you meant the number 0. So write none. Okay, that means vertical asymptotes. X is equal to 0. Okay. Horizontal asymptotes. There is none because your numerator is larger than your denominator. So again, we get to write none. Right? And you can write a happy face if you really want to. All right, so let's figure out this slant asymptote business. All right. So we're going to go ahead and we're going to say x on the outside. We're going to say x squared 2x plus 1. So x times what gives you x squared? X marks the spot. So x squared, right? Subtract. Bam. That was easy. So that goes away. Bam, bam. Bring down the 2x. X times what gives you 2x plus 2. So 2x. Bam. Subtract. Goes away. What are you left with? 1. So we don't care about the remainder. So what is our slant asymptote? Y is equal to x plus 2. Yay! Fantastic. Good job. Okay. So the next thing we are going to do is on your graph, right? Now, you actually have a graph that's labeled for you. I do not, because I left it at home. So again, I'm going to use these tick marks. So 1, 2, 3, 4, 5. Let's go up. 1, 2, 3, 4. Perfect. Hope everyone's having a great Wednesday, by the way. You might see me at the end of the period. So just FYI. Okay. So we have a vertical asymptote at x is equal to 0. So that is on your, obviously that is on your axis. So we don't have to worry about drawing it, right? So I'm just going to write, x is equal to 0 for that. But now let's go ahead and let's plot that guy right there, slant asymptote. So let's make a point at 2, and then slope up 1 over 1, up 1 over 1, all that beautiful stuff. Instead of going up, I can go down 1 over 1. All right, so this is going to be tricky. I'm going to put this down for actually a hot second. And you graph your line. Just keep listening to my awesome voice. Oh, yeah. There it is. Look at that slant asymptote. It's amazing. Okay, so the next question is, how in the heck do we determine where this graph actually goes? All right. So again, just like before, I said pick points to the right and to the left of your whole and or vertical asymptote. So I'm going to pick points to the right and left of 0. They're not going to cross slant asymptotes. All right. So if we're up in this section, then we stay up in that section. If I'm down here, then I'm going to stay down here. If I'm down here, I'm going to stay down here. Okay. So what's a good number to pick? 1. Fantastic. I thought so too. All right. So let's pick a point. So points. So let's say x is equal to 1. So let's plug it back into our original equation. So f of 1 is equal to 1 squared plus 2 times 1 plus 1. So 1 squared is 1 plus 2 plus 1. So 2 plus 1 is 4. So this gives you 4. So 1 and 4. You're somewhere right about there. All right, so that's our first point. 1, 4. All right, so let's figure something else out. So let's try x is equal to 2. So f of 2 is equal to 2 squared plus 2 times 2 plus 1. So what is this? 4 plus 4 plus 1. So 8 plus 1 gives you 9. So we're at the point 2, 9. So let's go back over here. 1, 2, 3, 4, 5, 6, 7, 8. Oh, barely made it in. Lovely. So 2 and 9. Oh, does it make sense? Yep. All right. So, oops. 2 and 9. So we're somewhere right about there. Right, so essentially what you are doing is you are following the asymptote. So it would be graphing down around here and then going up and stuff like that. Technically, you are getting closer and closer to this asymptote. So if you know that you're in this region right here with that 1 point, you can kind of just follow the asymptote. So it would kind of look more like this. That's why. So if we see, here's the 1, 4. So technically the 2, 9 should have been up here a little bit more. But again, we're just following the point. So we're following the asymptote, right? It's like, oh, look, I'm hanging out with this asymptote. I hit this point. Oh, I want to go over here. Okay. So I'm more right now concerned with, can you get the actual asymptote down and figure out kind of where you are, right? So again, if we look at the bottom one, so we're going to pick that -1 point. We're going to get that right there. And we're going to try -2 to see kind of what else we get. So that will be fun and exciting. Okay, so let's go back here. And so let's try x is equal to -1. So f of -1. -1 squared plus 2 times -1 plus 1. So -1 squared is 1 minus 2 plus 1. So that gives me 0. So -1, 0. We are right there. So now I know that I'm in this region, right? Bam. I'm in that region. Okay. But let's try -2 just for fun because I feel like it. Right? So f of -2, -2 squared. All right. So I got 4. And then 2 times -2 gives you -4. Wait a minute. Oh, -4. Plus 1. So, that is on the line. Well, that's weird. Hold on. Pause this. So, I feel very dumb. This is why I usually like to teach in class. I just realized, looking at our equation, I totally forgot about our denominator. So what do we need to do? We need to go back here and fix these points. So if I plug in 1, I get 4, but I still got to plug in 1. So this is still going to be divided by 1. 4 divided by 1 is still 4. So this point still exists. This point, though, does not exist still, right? I'm going to get 9. This makes more sense. 2 divided by, 9 goes into 2, right? 4.5. That makes more sense than 9. So cross that guy out right there. So 2 and here's 4. So 4.5 is probably somewhere right about there, right? So this makes a better look of the graph. Bam. Bam. Okay. So to recap, right? Do not forget to divide by the original denominator. Okay. I could just start this video over again and you would never know that I made this mistake and I'd be like a genius. But I want you to see the struggle is actually really real. Okay, so let's try -1. Now, obviously, -1, if I divide my answer by, 0 divided by -1, I'm still going to get 0. So that answer still exists. But let's go back to figure this one out, right? So 4 minus 4 gives me 0. 0 plus 1 gives me 1. But then I'm going to divide by -2, which gives me a -1/2, right? So if I go over to this problem, erase this beautiful work I just did. All right. So here's -2 and then a half. I'm probably somewhere right about there. So again, follow the asymptote. Again, you're never going to cross your slant asymptotes or your vertical asymptotes. All right. So once we're done, our graphs should look something like that once again. All right. So what I want you to do is I want you to try number 8. Okay. So flip it right back around. All right. So number 8 also has a slant asymptote. So try it, pause it. So the first thing you're going to do is you're going to find the PODs. Then you're going to find the holes in vertical asymptotes. Tell me that it's a horizontal asymptote is none. Then you're going to do long division. And and then pick a point to the right, pick a point to the left of your vertical asymptote and plot it. Pause the video right now. And when you are done with this problem, don't worry about domain and range and all that stuff. When you're done, press play, and I will show you the graph. All right? Good luck. I wish I was there to answer questions. All right. Ask each other if you need some help. All right. Pause. All right. So we're back. So here's our problem number 8 that you guys were working at. So we had, it's already factored for you, x plus 2 on the top, x plus 4 on the bottom, x plus 1 on the denominator. So the only thing in our denominator is x plus 1. So we set it equal to 0. We get -1. There are no holes. Why? Because there's nothing in common between the numerator and denominator. So that means our vertical asymptote has to be at x is equal to -1. All right, we don't have a horizontal asymptote this time because, again, hopefully you counted highest degrees of power 1, highest degrees of power 1. 1 plus 1 gives you 2. 2 over 1, numerator still larger than our denominator, right? This one, though, you had to multiply your binomials together. So, because I didn't pause my video. So if I multiplied x plus 2 by x plus 4. Sorry, got dim right there. I should have gotten x squared plus 6x plus 8. So your long division should be set up something like this, right? So x times what gives you x squared? That gives you x. So x squared plus x, subtract, boom, boom, cross off. I can't see that as a subtraction. 6 minus 1 gives you 5x plus 8, right? What do you multiply x by to get 5x? So plus 5, bam. So 5x plus 5, subtract, that cancels off. 8 minus 5 gives you 3 again. Do we care about the remainder? No, we don't. So again, notice it's x plus 5. And notice what I have, right? I have x. Where is it? Plus 5 right there. Again, don't worry. If you think about your domain, right, that is towards your vertical asymptotes. We'll talk more about that when I'm back, right? So hopefully you picked a point. You've plugged in 0. So if you plugged in 0 into this lovely equation, 0 plus 2 gives you 2. 0 plus 4 gives you 4. 2 times 4 gives you 8. 8 divided by 1, right, is just 1. So my graph is off by just a little bit. Again, this was from last year, so again, I should probably be closer up there at top, which is fine for 1 point. Okay, once I know that 1 point, though, again, that's telling me I'm going to follow this asymptote until I get to that 1 point and then take off the other direction, right? After another point on the opposite of -1, so we would try -2. So -2 plus 2 gives me 0. So no matter what, I'm at 0 on my numerator, so it doesn't matter what I'm at on my denominator. So again, notice that I'm right here. So now I know that I'm in this direction, right? If I try plugging in -3 and -4, again, I'm going to go up a little bit. Again, not too concerned about that. I just care about the actual shape of the graph, okay? So that's all about slant asymptotes. I just talked your ear off, okay? So I'm going to give you guys a different worksheet to do since we have done these last two problems kind of together. The only problem we didn't do, you can actually try it on your own, is number 6. So pause the video right now and try number 6. All right. So if you unpause the video and you try number 6, what you would have realized is there's a hole in there, right? X plus 3, they cancel each other out. What are you left with? You're actually left with a line, right? So I want you, when you simplify, you have a hole and things like that. When you simplify your fraction and things go away, sometimes you're actually not going to graph a rational graph, right? Number 7 is a rational graph because it can't be simplified, and we have x's both in the numerator and denominator. Same thing with number 8. We have x's in both the numerator and denominator, can't simplify. But unlike 6, we have an x plus 3 in both the numerator and denominator, so they simplify. They give us a whole, which we see on our graph as negative 3 comma 0. There is no vertical asymptote, which is fine. And if you don't have a vertical asymptote, you're not going to have a slant asymptote either. We're not going to have a horizontal asymptote. We don't have a slant asymptote. And this actually, the domain of range is pretty easy because it is a line, but you're going all the way from negative infinity all the way to your point, negative 3, and then continue on forever from down to up, right? Negative infinity to 0 because that's where your hole is, and 0 to infinity. Okay, don't concern yourself. The worksheet doesn't. I don't believe I put anything that looks like number 6. There are just a few questions that look like number 7 and number 8. All right. If you have any questions, I hopefully am back by that time. I should be back. If not, get on Gmail and you can always email me a quick question or two. I will have my phone on me and I can always respond to you. Okay. Hopefully this was helpful, and yeah, so luckily I actually have internet to upload this, and if it was helpful, maybe we'll do this more often when I'm absent. Not that I'm planning on being absent a lot, but maybe for the future. All right, cool, great, super, wonderful. Have your sub, I believe it's either Miss Gant or Miss Lopez Levalle in there, pass out the second worksheet. And if you want, you may listen to music. So you can keep the laptops on your desk and listen to music, or rewatch this video and kind of walk through the steps one more time. If not, email me. All right. I will see you guys shortly. I will also be in my room for lunch, so you can always stop by at lunch or very quickly after school. I will be leaving at 3:30. Sorry, I couldn't think of the time. 3:30. All right, cool. I will talk to you guys later. Bye.